Hey class, welcome to our first lesson in BC Calculus. We are going to pick up where you left off in AB. So in BC Calculus, we start with AP Unit 6, which is integration. I'm going to review some integration techniques that you saw in AB, and then I'm going to teach you some new ones. This first lesson is really just review of AB, so I'm just going to reinforce some things that you should have memorized and just some algebraic skills that are necessary when you're integrating. We are going to be getting into a lot of different methods, and so it's going to be really easy to be confused when you should use which method. And so that's something that we're going to focus on. And a lot of times what happens is we forget about the easier techniques, which is what I'm going to start with. So I'm going to start with the most basic part of integration, which when you're integrating, you're doing the antiderivative. So think about if you are taking the derivative of something, let's say like 3x squared. So when you were in AB calculus, if I wanted to take the derivative of this, I would bring down the 2 and then I would subtract 1. We are going to do the opposite when we're integrating. So I'm going to add 1 to my exponent, and then I'm going to divide by that number. That's all that there is to that problem. If I'm integrating x squared, I'm done. Now don't forget your plus c whenever you are doing indefinite integrals. And indefinite just means that we don't have boundaries, and I'll get to when we do have boundaries. But that's it for that one. When I'm talking about basic integration, I'm talking about that reverse power rule that you just saw. But sometimes you have to do a little bit of work to get there. And so that's where our Algebra 1 skills are going to come in. You might have to distribute. You might have to FOIL. You might have to use exponent rules. You might have to algebraically divide something or simplify or combine like terms. So all of these things that you would have learned forever ago, probably like 6th, 7th, 8th grade for some of you, we're going to bring all of that back. And that is often what kind of catches my students off guard. So you just kind of have to keep all of that rolling in your mind while you're solving through these. So the first example that I have, I've got the integral of x times a quantity, 3x squared plus 4. Now, all of my examples have x's, but these don't have to be x's. They could have t's or any other variable. It really doesn't matter. But you do want to make sure that this variable matches your dx. So with this problem, the first thing that I want to do is just distribute that x, okay? Now, this might not be the only way to do this problem. Eventually, we are going to talk about u substitution. I could actually use u substitution to solve this, and that's fine. Sometimes there's more than one way to solve a problem, but we are focusing on the basic skills right now, and honestly, I think this might just be easier. So let's just distribute. Once I distribute, now I'm going to do that reverse power rule, but instead of on just one piece, I have 2 pieces. So I'm going to add 1 to my exponent and divide by that. Now, if the 3/4 would simplify, go for it. It doesn't. I think it's going to happen here on the next one, though. I'm going to make that a 2. Yeah, so I could write it as 3/4 with an x to the 4th over to the side like that. Or I could have it how it previously did. It's up to you. And I'm going to simplify that to the 2, and don't forget your plus c because it's indefinite, okay? On your practice, if you forget to type in that plus c, it is going to mark it wrong, so remember the plus c. Okay, so the next problem that I have looks kind of bad. Okay, we've got a fraction, we've got a radical, we've got multiple x's. We are going to clean it up. We're going to make it look a little bit better by, let's just think about our exponent rules for a second. I can rewrite this problem. And sometimes you may not know where to go or how to start, but just do something that you know is true. So I've got the square root of x, which is the same thing as x to the 1/2. Okay, that's something we would have done a lot in AB with chain rule. Now that I see that I have two x's, I can use my exponent rules. When you're multiplying, we're going to add. So I've got a 1 plus a 1/2, which would be 3/2. Squeeze in my dx there. Okay, so that's a little bit better. We're down to 1x. We got rid of the square root. The only thing is we have a fraction, and what's going to be helpful when you have a fraction is to remember another exponent rule. When you flip that, so if I flip these two around, that is just going to make that negative. I can put it over a 1 or not, it doesn't matter. Now I have something I can work with. I can do my basic power rule. I'm just going to add 1 to that. So if I add 1, get rid of that integral symbol, I'm going to add 1 to negative 3/2. So if we add 1, get a common denominator and add straight across, that would be negative 1/2. And if you can do that just in your head, that's great. I just wanted to show that you can always go off to the side and add your fractions if you need to. I could leave my answer like this. Let me just divide by negative 1/2. That looks a little gross, and you probably, if you're taking the AP test, you're probably not going to see your answer like that. So if you just remember when you're dividing fractions, leave, change, flip, we can flip this guy around. So that'd be negative 2x to the negative 1/2. This is an acceptable answer. It's fine. There is one other thing we could do, and that is, I'm just going to kind of go over here for a sec. We could put that back in the bottom, and we could also put the radical symbol with it. So there's more than one way that your answer could look. They're all equivalent, they're all right. If the question specifies, like, you don't want any negative exponents, or if you're taking a multiple choice test, make sure that you're able to find the one that's equivalent to it. And that's kind of what the AP test will do, is we'll test you on a lot of your exponent rules and on a lot of your just like kind of algebraic manipulation, and can I find the answer that matches up with mine? Okay, so with the last problems, we were kind of focusing on more like exponent rules, distributing. I'm going to look at a couple of division problems, and there's more than one way that you could do this one, but I do want to just remind you of something that's pretty simple that would make this problem a lot easier to solve. Because once again, we are going to be learning some crazy techniques. We're going to be talking about integration by parts and use substitution. And you might try to use one of those more advanced techniques when you could just do this one simple thing. So if you ever see like multiple pieces divided by one piece, so a monomial, then what you can do is really just kind of take turns and divide every single piece by that one denominator. So I like to call this like butterflying, but whatever works for you. To me, like once you circle this, kind of looks a little bit like a butterfly. So x squared over x is x, and 1 over x is just 1 over x. There's really nothing I can do with that. Now that I have these two individual pieces, I can just integrate them individually. So I have a basic power rule problem where I'm just adding that 2. Now you may or may not remember this. Whenever you integrate 1 over x, that is ln of x, and we want to put an absolute value around that since we don't know what x is. And then don't forget your plus c, and that's it for that one. This next division problem is a little bit more involved because I don't have a monomial on the bottom, so I can't do that little like butterfly thing I did. What I have to do is polynomial long division. And if you prefer with the last one, you could have done polynomial long division. but much easier to do what we did, I think. So if you remember how to do long division, great. If not, I am going to go over it quickly, and you'll get a chance to practice this more in your assignment. First thing I'm going to do is I'm going to set this up to look like a division problem. Now, the first thing you want to make sure is that you don't have any like gaps in the powers. So like inside I've got a 2, a 1, and then there isn't an exponent, and then I've got a 1 and a 9. What you would want to watch out for if there's something like if you're jumping from x squared to a -4. And also you may be able to just like factor and cancel. Think back to like algebra 2 when you were simplifying rational expressions. That could work too, if you want to try to do that. I don't think that would work in this case, but sometimes, like I said, there's more than one way to solve a problem. All right, so when I'm doing polynomial long division, I'm going to focus on these first two pieces. And luckily in calculus, the long division problems that we see are normally not too bad. We have to ask ourselves, what could I multiply to x to get x squared? And that would be x. Once you figure that out, you just need to re-multiply that to both pieces on the outside, and you're going to subtract. Now watch out here because I have this double negative. Luckily this cancels out. That should happen every single time, but this double negative is going to turn to a positive and bring down the -4. I'm going to go through that cycle again. I'm going to ask myself, what do I multiply to x to get 3x? And I'm going to put a +3, redistribute, subtract, drop that double negative again, integer operations. So it looks like I have a remainder of -1, and I'm going to put that remainder over x minus 1. I always like to add on my remainder just in case if that numerator had multiple pieces. So you may feel like, wow, I just did a lot of work, I'm done. Well, you're not, because we have to still integrate. We have 3 pieces here. So I'm going to have to integrate x and 3, and then this -1 over x minus 1, if you want to write it like that. So I'm going to integrate all 3 of those pieces individually. So basic power rule, like I mentioned on the very first slide, we're just adding on an x and dividing. Now this looks a lot like 1 over x, and so that's going to be ln of x minus 1. I'm going to talk more about that in another video, but for now we are good to just move on from that. I just want to show you that you can use long division to break up a problem and then use your reverse power rule. That's really everything that's going on in that first half with all of those problems. Even though they looked very different, they all were using that basic reverse power rule where you add 1 and then divide by that number. I want to show you a couple of AP type problems that you might see that relate to basic integration. This is a problem that normally will throw off a lot of people. Same thing with like, maybe integrating pi. If we're integrating e or we're integrating pi, those are just numbers. I don't treat that any differently than if I was integrating like 3. If I'm going to integrate 3, that's 3x plus c. I'm just adding on an x. So e is just a number. I'm just going to add on an x. Or if I had a pi, I would just add on an x. And then don't forget your plus c. So with this problem, I have 2 separate pieces. I have an e to the x. Remember that the integral of e to the x is just e to the x. So we are looking for something that has e to the x as the first piece. And then the second term is e, and we're just going to kind of slap on an x with that. So that would be this choice. So it's actually a pretty simple problem, but this is normally something that will throw people off. Just remember that, those are numbers. Or sometimes on the AP test, you might see like a k, and that k is a constant. We'll just treat it like the way you would treat a number. All right, I do want to quickly go over definite integrals because everything I just talked about was indefinite, but if you can do those previous problems, you can do this one. And so I just want to review what to do with those boundaries. So the first thing you're going to do is integrate the way you normally would. So the integral of 1 over x, ln of x, the absolute value. The only thing that is different is I'm not going to have a plus c. I have to actually plug in these values. So remember from AB that the lower boundary is your A and the upper boundary is your B. And we do always want to go from bottom to top. If you flip those around, that's going to affect the whole problem and make that negative. So once you have it integrated, we're just going to plug it in. So plug in 3. And then you always want to subtract. And here's where you'll kind of have to watch out because sometimes like you'll be subtracting a negative. And so it's a simple algebra 1 thing, but it does happen. If you remember, ln of 1 is 0. So that's going to kind of go away. So my answer would just be ln of 3, and I'm done. If that was not an ln of 1, I'll do a little sidebar here real quick. Let's say it was ln of 3 minus ln of 2. If you remember from pre-calculus, whenever you are dividing or whenever you're subtracting, that turns to division. So I could do ln of 3 halves, and whenever you have addition, that would be multiplication. So that's another thing. If you are taking the AP test, they'll throw in those kind of like pre-calc rules on that test in the multiple choice questions. I do quickly want to talk about if you see average value with basic integration, all that means is you're going to integrate it the way you normally do, but you have to multiply it by 1 over b minus a on the outside. So if I were asked to find the average value of this problem, the only thing I'm going to do is do my b minus a. So that would be 1/2. We previously integrated this problem. It was ln of 3. So that would be my answer. So if you see average value with integration, that's all it is. Just throw in that 1 over b minus a out front. The final thing that I want to go over in this video, and I'm so sorry, I know I'm going over a lot, but this is all really just kind of review from AB, just to kind of like wake up your brain from taking a break from calculus. So there are a lot of things that you just need to memorize. Unfortunately, like there's not going to be a trick for everything. Sometimes you just have to know something. So we already talked about how e to the x is e to the x, and we had talked about how 1 over x is ln of x. Make sure that you know all of your trig stuff and your arc trig. This is a common one that you'll see. A to the u is equal to 1 over ln a times a to the u. So, and that can also look like this. I will include after this video a memorization sheet that just has a lot of BC Calc memorization things if you want to print that off, but that's where this clip came from. So if you would like to have that. These are a couple of AP type problems that are just practicing that memorization. So, this problem throws off a lot of people because I think we're used to having like x to the second, and we know that reverse power rule, and that's really easy. But this is 2 to the x. So if you have a number and then your variable is an exponent, that is actually going to go back to this rule that you need to have memorized. And so if we look through the choices, that would be this. A lot of people will pick D because they're thinking that reverse power rule, or they'll pick A because they're thinking of like, oh, like e to the x is e to the x, so why isn't 2 to the x to the x? Well, it's not. The other thing is just knowing all of your trig and arc trig. And so, I'm given the derivative as tangent. So what is the of the antiderivative, what is y? So once again, this is just one of those things that you have to memorize. Sometimes what helps me is, thinking back to like AB and thinking about, when I take the derivative of, this, I get this other thing. Like if I'm trying to integrate cosine, then it might be helpful to think about, oh, when I take the derivative of sine, I get cosine. So, you kind of have to think like, what would I take the derivative of to get tangent? We're kind of like working backwards. And if you remember, it's secant squared. So there's really no like method to these types of problems on the AP test. You really just have to have those things memorized. Once again, there is a memorization cram sheet for this course and just to help you get ready for the AP test or for your final exam, and that will be linked after this video. I know that was a lot of material, but it's really important to have the basics down before we get into our next methods of integration.